All right, yesterday we talked about integers being negative numbers and their opposite positive numbers. Today in lesson 2.2 we're going to talk about rational numbers. Now don't let this word scare you. See if you can notice the word ratio in the word rational. This will help us know what rational numbers are. Rational numbers are any number that can be expressed as a ratio. And a ratio is simply, I drew right over the top of that word ratio. I didn't mean to. Ratio is really a fraction, as long as the denominator does not equal 0. And if it isn't, it's a fraction, it's a rational number. So here's what it looks like in algebraic fancy terms. If you have a number divided by a different number, as long as that other number is not 0, and I'm not going to get into why, but just trust me on that. This is a rational number if it can be put into a fraction. Sometimes you'll see negative fractions, and the reason I have these here in green is just to show you they can be written different ways. The negative might be out in front of both numbers, like kind of in the middle. The negative might be in front of the top numerator, or it might be beside the bottom denominator. They all mean the same thing. So down here I've included some examples of rational numbers, numbers that can be put into fractions. Simple one, 3. Any whole number can be written as a fraction. You can put 1 underneath it, still means the same thing. So 3 can be written as 3 over 1. Negative 9.2 can be written as negative 92 over 100. And when you divide that, this is what you get. So it can be written as a fraction, so it's rational. Same with 4.5. That is the same as 45 divided by 10. So that is a fraction. And so 4.5 is a rational number. Negative 10 can be written as negative 10 over 1, kind of like what we set up here with 3. So negative 10 is a rational number. Something like this, the negative 0.01 can be written as negative 1 over 100. So it is a rational number. Rational numbers, again, can be written as a fraction. All right, next, I'm going to show you that we can graph rational numbers on the number line. We call the point where we graph them a coordinate. So we can graph the point on a number line. All I did was take the numbers that we had up here and I put them on the number line for us. So here's where negative 10 is. And here, over here I put negative 9.2, which is, this is my fraction, just to show you. Here is negative 0.01. It would actually be really close to that line, but I just had to put it there to show you that you can graph it. 3 was simple, right on the line, and 4.5, 4.5. There it is on the number line. So we can graph rational numbers on the number line. We can also compare rational numbers. Some are greater than others, some are less than others. We're going to use the same signs we do for integers. And you look at where they fall on the number line to decide if it's greater or less. So 1.38 is less than 1.83 because it has a smaller number in the 10th place. Negative 3.45 is less than 1.32. This is on the negative side of the number line. This is on the positive side. Negative 4.23 is greater than negative 5.23 because on the number line, negative 5 is further to the left than negative 4 is. So it's going to be smaller. When we compare fractions, hopefully you remember that you need to find a common denominator before you compare them. So when I compared 3/4 with 5/8, I found the common denominator of 8. I multiplied 4 by 2, so I need to multiply 3 by 2, so I got 6/8 is greater than 5/8. So in essence, 3/4 is greater than 5/8 because this is an equivalent fraction. Another one using negatives. -2/3 and -5/8. How do they compare to each other? Well, I found the common denominator of 24. I had to multiply 3 by 8 to get 24, so I'm going to multiply 16 by 8. Sorry, I'm going to multiply -2 by 8, so I got 16. So we have -16 over 24. And then I had to multiply 8 by 3, so I need to multiply 5 by 3, and it's negative, remember. So 5 times 3 is 15, so we have -15 over 24. So here's our equivalent fraction. And I know that -16 is a little further to the left on the number line than -15 is. So it is less than. So in essence, this is my fraction I started with up here. I can write that -2/3 is less than -5/8. And we'll be working on some of those. Lastly, I do want you to draw this. This helps you see the relationship between the numbers we've discussed so far. I'm trying to get all that on the page. So we're going to start out in the middle. When we start counting when we're little, we count 1, 2, 3, 4, and so forth and so on. Those are called natural numbers. When 0 is introduced, they now change to what's called whole numbers. 0, 1, 2, 3, 4, so forth and so on. Yesterday we talked about integers. Integers are when we have the opposite of the whole numbers on the number line. So -3, and keeping on going backwards that way. -2, -1, 0, 1, 2, 3. Keep on going this way. Today we talked about rational numbers, and we know rational numbers are what can be formed into a ratio, which is a fraction. And these right here are examples of rational numbers that can be put into fractions or are already fractions. And all of these numbers we talked about fall under the category of real numbers. Because believe it or not, yes, there is a category of math called imaginary numbers. But don't let that worry you. We're not going to talk about that right now or anytime soon. So in the lesson to follow, we will be knowing this. We will be comparing these rational numbers. We'll be putting them on the number line and deciding whether or not a number is rational. Can I put it into a fraction? Thank you very much.